Good morning, students. Welcome to the statistics class. And I hope you people are all doing good. Okay. And I also hope that you have watched all my videos and have understood all that has been explained to you. So I said in the previous video itself that almost our theory portion of statistics is getting over. Now we are entering into a kind of a numerical problems. Okay, so now in the previous video, students, I have taught to you regarding frequency distribution. In the classification and tabulation, I have taught you regarding frequency distribution. I told you there are two types of frequency distribution: discrete frequency distribution and continuous frequency distribution. Right? In discrete frequency distribution, very simple definition says where if class intervals are not considered, then that frequency distribution is called discrete. If class intervals are considered, then that distribution will be called as continuous frequency distribution. So in continuous frequency distribution, I have given you all those explanation regarding the ways that we can arrange continuous frequency distribution, that is open-end, inclusive and exclusive, and all the terms that are used in continuous frequency distribution I have explained to you. So now what is that we have to study at present is how to form frequency distribution. If the data is given to us, right, how should we form a frequency distribution? How to form a discrete frequency distribution, how to form a continuous frequency distribution. So let us first start with the discrete frequency distribution, students. So discrete frequency distribution, when we say, so let's take one simple example which is there in the textbook, students. In the textbook, example number 1, which is there and which is displayed on the screen for you right now. What is it? In a survey, students, you can see here, you can very well see that okay, right, you can very well see that um, in a survey, in a survey you can see here, in a survey of 40 families in a locality, the number of children per family was recorded and the following data were obtained. So imagine you have conducted a survey, students. You have conducted a survey, and that survey was all about to know number of children per family. Now you've been asked to go and collect the data from 40 family students, and now when you went and collected the data for 40 families, this is the data that you got. The first family you went and they gave us the data as we have only one child. The second family you went and asked how many children do you have. The second family said we don't have any children, 0. So, and the third family, when you went and asked how many children, we have 3 children. So like this, they have given us the data. How many family students? 40 families. Okay, and this is the data that you have. Now represent the data in the form of discrete frequency distribution. They have already mentioned what frequency distribution it should be. It should be discrete frequency distribution, very clearly. Discrete frequency distribution. Sir, if they say represent the data in frequency distribution, how should we know whether it is a discrete or whether it is a continuous? Right? It depends upon the variable. The variable for us is here number of children, students. This is number of children, okay, per family. This is the variable. So number of children per variable, this is a discrete frequency distribution, students. This is for us a discrete frequency distribution. Why do you say it is a discrete? Because by nature the values of number of children per family will never be in fractions or in decimals. They always will be in a whole number, as a whole number, as an integer form. And at the same time, the values also will not have many, but the values will be very few, students. You understand? Very few. The range of those values will be very few. So that is why we can say for example, number of children, number of goals scored by a football player, right? Number of, you can say, speak about accidents happening in a city, right? Number of suicides in a city, right? Number of telephone calls and a receiver will receive, right? All these kinds of, variables where by nature they will never be expressed in decimal form. So that is what we have it here, students. So what I will be doing it here for you is, students, right? I will be making this whole frequency distribution in a rough format. We will just try to make it, students. Okay, right? Okay, fine. So let's first, what we do is, let's start with what are the values, maximum values we have, what are the minimum values we have. Let us write it so that it will be easy for us to understand and frame the frequency distribution. What is the maximum value here, students, in this whole data? Which is the maximum value that you can see? The highest value you can see. The highest value that you can see is 6, students. And what is the minimum value that we have it, or the least value that we have it? The least value that we have it here is 0, students. Is it right? Is 0. Okay, so with this you can easily identify and do what best you can. So what would be the first column for me? The first column would be number of children per family. This is what I will write. This is the variable for us, number of children per couple. Okay, I'll denote this to be as x, students. I'll denote this to be as x. X is a variable. This is a variable. So what are the values taken by the variable? It is 0, it is 1, it is 2, it is 3, it is 4, it is 5, it is 6. Is it right? So the next column would be for me is tally bar, students. Tally bar. Okay, based on that we can write it. And the next column would be for me as, number of families. Okay, number of families. So when it is number of families, right, how do you represent this number of families? How many families have no children? How many families have one child? How many families have two children? That means we are writing the number of times that value is repeated. In other words, for us, this itself is frequency. Okay, so this is what we need to do, students. Okay, so let's start how to do this tally bar. Number 1. Okay, see this, number 1 is there. So number 1 is here. So what we need to do is, we will put a tally against the number 1 here. We put a tally, one tally, right, and mark it as red. The next value is 0. We put a tally for 0 and mark it as red. Next we have 3. Okay, we put a tally for 3 and we mark it as red. Next is 2. We put a tally 2, right, for 2 and read it as 2. Okay, then next comes 1 again. 1, read it. Then 5, okay, read it. I hope you're following it. 6, read it. 2, read it. Again 2, we read it. 1, we read it. 0, we read it. 3, we read it. 4, we read it. 2, we read it. 1, we read it. 6, students, 6, we read it. 3, we read it. Then 2, when it comes to 2, 1, 2, 3, 4, already 4 lines, then I'll put one more like this, which indicates that as, students, which indicates it as 5 times it is done. Okay, so I will write it this as, right, 1, 2, 3, 4. Okay, so we have already 1 is been read 4 times. Okay, so we will write it as 4. Okay, now this is 5, students. So now read, next is 1 also carries. Okay, so then next 5, then next 3, again 3, next 2, next 4, next 2, again 2, then 3, then 0, 0, then 2, 1, 4, 5, 3, again 3, 4, again 4, 1, 2, 4, and last is 5, students. So if you write this, so we'll see the number of tallies here. Okay, number of tallies for 0 is 3. So I'll write it as 3, 0, 3. Number of tallies for 1 is 7, 0, 7. Okay, number of tallies for 2 is 10. Number of tallies for 3 is 8. Number of tallies for 4 is 6. Number of tallies for 5 is 4. And number of tallies for 6 is 2. So when we add all these students, we should get the total as 40, and this is what we call it as for us as a total frequency, students. So let's see. Okay, 3 plus 7 is 10, 10 plus 10 is 20, 28, then 34, 38, and 2, right? And this 40 is called as n, or it is sum of all f, students. So this is how we do it, students. Okay, this is how we have to do it. So when we check it out, see if we have to see whether 1 is written 7 times. Let's check it out with a simple understanding. We'll see one verification we'll try to do whether our tallies are right or wrong. We will just check taking only one example, one value. Okay, let's see. Okay, let's see 0. If you say 0, how many times it is seen here? 1. Okay, 1, 2, and 3. Is it right? Correct. Fine. Then if you speak about 1, 1, 2, 3, 4, 5, 6, 7. It is 7 times. Is it right? So that means these are very important for us students. These values are what they are frequencies. So this itself, right, whenever we are making it, these values should be correct, students. This is not important for us. This is not important. This 40, by default you will get 40. That is not a problem. But what is important is these values should be perfectly done according to the data, according to the values, number of values given to us. So these values are important: 3, 7, 10, 8, 6, 4, 2. Everybody should get the same tally or same number of tallies or same frequencies. Then only it is perfect. So that is what we will be doing it, students. Okay, so I hope you have understood about this kind of a discrete frequency distribution, students. Is that clear? Okay, thank you. We will go to the next video. In the next video, I will teach you about a continuous frequency distribution, students. Okay, thank you.